我就是你不用动，我就保住那边。我买了很多零食吧，忘记带了，明天带了啊。Okay, we're close to the end of the semester already. So there's one last assignment and one last project. Okay. Um, I put out the scope for the project already. So what you need to do for the last project is basically you need to read um, the last chapter of this course. So you can find in this book I listed down here. So read these chapters in this book and then try to make a summary of them. Okay. So in your summary, at least provide one proof. Okay, at least provide one proof in your project. At least. Okay, you can do more, but at least one. And come up with 1 to 3 possible exam questions. Okay, on this topic, on the sequence and series of functions. Okay, for this last project here. Question, what you need to do. Do you have any questions you want to do on the last project? Anyone? Citing? Yeah, you can cite. Yeah, cite, just cite where you get this um get these get these theorems from. No need to cite on every theorem. Just says where you get these theorem or example or what. Okay, so this last topic is also the last topic we will pursue in this course. Okay. Yeah. Any question? Question on what to do on project 2? Don't have any much format. Okay, you just provide a summary and then give 1 to 3 possible exam question with solution. And so the point of this project is I want you to do revision and then make a proper notes on your revision. Okay, and then do some exercises, and then you think that, oh, this exercises is quite good, and then help me to understand the knowledge, or maybe it will be in the exam. Okay, put it in. Does it make sense? Make sense or not? Okay, so the deadline for this project will be the Friday study week, and then project 1 is Friday next week. So can you check that you guys are enrolled in the Moodle or not Moodle, the Turnitin? I enroll you guys into the Turnitin. So the process is similar to what we did last time. So you need to submit your report to Turnitin, and then you need to submit report, Turnitin report, and then slide. And then I'll give you cover page. Okay. So you can start submitting your draft again if you want me to check again this week, next week, like that. Okay. Otherwise, you just do correction based on what you presented, and then based on what I told you in your slide. Okay. Yeah. Okay. Now, is it clear for what you need to do for all the projects and assignment? Last assignment that due this week, is it? How it goes? Any question or not for your assignment? Okay. Yeah. Feel free to ask. And come to my office hour also. Okay. So I will put out the notice again for this project one, project two, and the detailed submission instruction or what you need to do again on Moodle, on Teams. Okay. Yeah, if you have any question, then feel free to ask. Okay. So last time we talked about point-wise convergence. Can someone recall what the point-wise convergence means? Huh? What does it mean by Fn converge to F point-wise? Oh, so what does it mean by Fn converge to F point-wise? If if for every point, okay, in the domain of Fn, okay, such that for every epsilon greater than 0, there exists an n such that for all n greater than n, Fnx minus Fx is less than epsilon. Okay or not? Okay, so what's the difference here? Our sequence become a sequence of function. Okay, and then pointwise convergence, we just check at every point x. Okay, we check at every point x. So what happens now if you substitute your function with an x? Get a number. So this function, this function is defined on a domain, okay, to a um, to the real number column. Okay, so these are real value function. Real value function. Okay, so these are really just a real number. Okay, so pointwise convergence asks for convergence of sequence of 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 what? Real number. Okay, so this is pointwise convergence. Okay, let's look at some example. Okay, let's look at example. I let you try example. So I give you a few examples. See if you can guess what does this function converge to. Okay, let's draw some example. Okay, I want you to discuss with your friend. Okay, what's the pointwise limit of this function? I will give you a few to work on. Okay, this is the first one. Hello, welcome back. And then let me try the other. About this one. Okay, let's see. Interesting one. Okay, how about this one? Then the fourth one. Yeah, let's first discuss about this one. What is going on here? Then I want to make this pyramid run. Okay, and it run away. Okay, can everyone understand what this sequence are doing? Sequence of functions doing here? Understand or not? Understand what these sequences are doing? For the first one, when when n increases, what happens to this function here? Huh? How do you imagine this function for the first one? When n increases, what happens? The triangle get smaller. The height is still the same. Okay, but the triangle gets squished. Can you imagine or not? Can you imagine? So basically, I want this middle point to be 1 over 2n. Okay, so the triangle get squished, but the height is still the same. Make sense? Can see the you can imagine? Imagine or not? When n get big, right? You get 1 over 2, 1 over third, 1 over 4, 1 over 6, closer to 0. Does it make sense? Okay. How about question 2? What happened when n get large? Yeah. Also, the triangle will get smaller, but this one is coming smaller on both sides. Okay. How about 3? When n get large, what happened? The slope here will get steeper and steeper, and then you get more 0 point here. Okay, no? Okay, so you can imagine this point here keep moving in. Okay, then the slope will change with this point. How about the last one? What happens when n get large? Both points are moving. Okay, so you can think of it as a running pyramid. So this pyramid run. Does it make sense? Okay, so now I want you to guess. Okay, discuss with your friend. What is the pointwise limit for this for function? Okay, what's the pointwise limit for this for sequence of function? Okay, try I give you 5 minutes to discuss. Give me the pointwise limit of this function. Okay, try to write down the pointwise limit. Okay, try to write down what does this function converge to. All four, yes, all four. This one is pointwise, huh? Pointwise. Which point, huh? Which point you need to discuss? What do you think? Discuss the point, all the point in your domain. Okay, so what's the domain for 1? No? No? -1 to 1. Okay, because my function got all the red line. Question 2, -1 to 1 as well. Question 3, should be -1 also. -1 to 1. Okay. Question 4, actually I extended infinitely, so it's R. Okay. Yeah. So 3 of them is -1 to 1, 1 of them is up. So you need to discuss all the point in your domain of your sequence or function. Then try discuss with your friend. What is the pointwise limit you get? Okay, this is to train your intuition. What you should get. It's the function that converge. Okay, let's try. Okay, let's try. What do you think the first um, sequence of function converge to? What do you think the first function converge to? What's the pointwise limit? What do you think? What's the function at every point? Alright. So this n start with 1, right? And this n start with 1. So remind ourselves how the sequence started. So the first thing you had should be 1 to 1/2 and then to 1 like this. Right now. Okay, and then second, what do you have? 1 to 1 to the 4th and then to 1/2 and then 0 all the way. Okay, so I mean we can write this piecewise function down, right? So how do we write this piecewise function? So basically we split into how many parts? What do you think? Huh? 3 parts. Not enough, right? We should break into 4 parts. Right, so there are 2 zero part here, and 1 linear part, and then the other opposite linear. Okay, so there are 4 parts here. So basically, we break into 4 domain, 4 region, -1 up to 0, and then 0 up to 1 over 2n, and then 1 over 2n up to 1 over n, okay, and then 1 over n up to 1. Okay, so for the first part and the last part, we should put a 0. How about the linear one? Can you compute the gradient or not? Can you compute the y equals to mx plus c or not? Okay, so you should take the, so you need to put in what you have learned. No? Okay, you need to take the 2 points and then compute their gradient. Okay, because this is just a linear graph. So for the first part, you should get 2nx. Okay, for the second part, you should get 2 minus 2nx. Does it make sense? Okay or not? Make sense or not? Do you know how to compute the gradient for linear graph? Yeah. So for every point, right, what can you see from this graph? So if we want to check for every x, what's the limit of f and x? So let's say I randomly pick an n here, x here. Okay. What is the limit of f and x at this point? What is the limit of f and x at this point, for example? For example, let's pick, let's say, let's say we pick, say, pick x equals to maybe 1 over 100. Okay. How small is x equals to 1 over 100? Maybe around inside here. Correct or not? Then we want to check what is f1 on this guy, f2 on this guy, f3 on this guy. Correct or not? Okay. So how do you see from this example here? So this fn definition depends on the number you put, okay, on sequence of function. And then what is f1 here? f1, what happened to f1? So you need to put all the n as 1 here. Okay, so if you substitute n equals to 1 in this domain here, where is 1 over 100 lies in which category? The second one, is it? 0 up to 1 over 2. So it lies in the second category. So second category give you what? 2x. 2 times 1 times x. Your x is 1 over 100. So it's 1 over 50. How about 2? When n equals to 2, where is 1 over 100 lies? Which category? Also, second, right? Because when you sub n equals to 2, what do you get? You get the second category to be 0 to 1 over 4. So 1 over 100 is lying in the second category again. So you still get 2 times, but this time n is 2. So 2 times 2 times 100. You get 1 over 25. Okay. How about 1 over, I don't want to do 3, maybe do 4. Okay. Do 4, what happens? Still live in the second category. But what do you get instead? You get 2 times 4 times 1 over 100. So what do you get? You get 50. You get 2 over 25. 2 over 25. Is it? Yeah, seems like it. Okay. And then maybe you can try more. Okay, you can try more. Let's say try out to 4 of 200, f of 100. What do you get? Which category it lies? Huh? Third category. Okay, so third category, what do you get? 2 times 2 minus 2 minus 1. 2 minus 2 times 100 over 1 over 100. What do you get? You get? What do you get? 0? 0. So what can you see? What can you see from this number here? What can you see from the number here? Okay, let me move down. Yes. Okay, what can you see from the number here? When n get large, right? You can think like this triangle here will eventually pass by the 1 over 100. Okay, so for large n, what happened? This 1 over 100 will always lie in the fourth category. So what's the fourth category? It is always 0. Does it make sense? So what I want to say here is for every x, okay, you can find 1 over n that is less than x. So you can take, because it's the Archimedean property, right? Okay, take any point x that exists some n such that is greater than 1 over x. So if you turn that over, this is the this is the n that will give you that the point will always live in the fourth category. Does it make sense or not? Does it make sense? So like this. So this is my claim. So let's put down the claim. Claim for every x in minus 1, 1, limit of n to infinity of f and x is 0. Okay. So what do I need to show? I need to show that for every epsilon greater than 0, there exists an n such that for all n greater than n, f and x minus 0 is less than epsilon. Okay or no? Okay. So what n you need to choose here? Okay, so my claim just now was to choose n such that what? Such that, okay, so I think we need to split into two cases, right? So if you need to show for all points in minus 1 to 1, but we know that from minus 1 to 0 is always 0 already. Correct now. So what we need to care about is all the points from 0 to 1. Okay, so for the point in minus 1 to 0, we know that f and x is already 0. Okay, so now what we need to do is now consider the point from 0 all the way up to 1. Okay, so my point is choose n greater than 1 over n. Sorry, n greater than 1 over x. So consider x in this region. Consider x in this region. So we can choose this by Archimedean property. So what happens if I choose this? I know that x will be greater than 1 over n. So what do I do? Then for all n greater than or equals to n, what happened? We will know that fn x is equals to 0 always. Does it make sense? Any question? Please, you need to ask question. I don't want to teach it like how to say, know how to calculate but don't know what's going on. This thing can easily be condemned. So you need to ask question. Any question? Which line you don't understand, just ask. No need to think that much because I'm here. You need to think when you are on your own. Any question? You know what am I talking about? You know what's the idea or not? Do you know what's the idea? Yes. 哪一个是被选的？哪一个是which one is chosen? Which is chosen? 哪一个是被固定住的？Big N，小 n 只是说后面的那些数字大过 n， 可以吗？就是 I mean we can change this. So this is the concept about bound variable and free variable. 哪一个是可以变的，哪一个是被选好的 ？Bound variable and free variable. N is fixed. Okay, so n maybe we can change it to like I can change it to x also. Then here we will talk about fx. Sorry, x is not a good one. So I mean, for this sentence, I can change it to for all the number m greater than or equal to n, fmx is 0. Okay, but n I cannot change. N is the one I chose already. Okay, I chose it in this way, fixed. So n can be 100. Okay, and then for all the number beyond 100, then I have this satisfied. Okay, so for example, f101, f102, f103 should get the 0 number. Does it make sense? So what I want to demonstrate is there exists an n such that this triangle will have 0 on this point here. Does it make sense? So how do you write that down? Okay, how do you write that down? So you need to make sure that your 1/100 is lying in the which category? Fourth category. But how to live in the fourth category here? What's the definition? As long as your s has to be greater than 1/some n. So you need to find this n for me. How to find this n? This n can be given by the Archimedean property. Okay, so if you found this capital N that's greater than 1/x, what this inequality give you is x will be greater than 1/n. So if you set your fn to be 0 on the region 1/N to 0, you will make sure that fnx will be living in the fourth category, which is equal to 0. Does it make sense? 合理吗？合理这个东西很重要，你知道吗？因为在 FYP 听到很多不合理的东西，我听到我很抱歉，浪费我时间，你明白吗 ？FYP 你们也是要进入 FYP 还有几年？ 1年是不是？1年半 ，OK， 很重要啊！不要讲一些废话那种 FYP， 讲一些你不知道的东西，你明白吗？所以现在就要开始学啊，什么叫做 make sense？你要对你自己你自己理解 ，OK， 然后你要用你的理解去做问题，看一下你的理解跟大家理解的东西一不一样，所以你要一直匹配你的理解和大众对这个东西的理解，你明白吗？OK 吗？学生普遍有几个问题：一，不理解；OK，二，他用自己的方法理解，但是理解错的，这都是不对的，全部都要改，OK 吗？全部都要换，然后你才会做的东西才会跟大家匹配，明白吗？Does it make sense? Make sense or not？合理吗？我以前上大学的时候，第一件事，老师或者 tutor 讲的东西就是 make sense。那时候我也不明白什么叫 make sense，我也是马来西亚上来的，老师叫我们做我就做梦，他叫我们要 make sense，我听不懂什么叫 make sense。老师讲要 make sense，我不知道什么叫做 sense，我没有 sense。所以你要 train 你的 sense，你知道吗？OK，要 make sense。OK，come back to here. Any question about this? What you need to know? What you need to show? So the problem is that for every epsilon, I can find an n. But how do I find this n? I automatically find this n using the Archimedean property here, such that I already get 0 for fnx. Again, no need to worry about what epsilon you give. I straight away give you a condition. I can get 0 for all the small n greater than this capital N. Yes. Yes, try. No worries.
You don't is but you either all about only the given to one.
What do you mean by split case? Split to what cases? You have to split. I already split to 2 cases, right? -1 to 0 and then 0 to 1. Yes. Okay, good. So our function is 4 domain here, but I can discuss all the point from 0 to 1 at once. My argument works for all points here. This is my point. So I don't need to split further. Does it make sense? My argument is enough to discuss all the point here. No matter what x you give me, okay, inside this region, whole argument here makes sense. Okay or not? Yeah, so I don't need to split further. Why I want to split into 0 to 1 and -1 to 0? Because -1 to 0, there's nothing more to discuss. No matter what n here, the fns always 0. Always. No need what n1. All the n is 0. Okay, but the problem is here, you see? The problem here is C. Yeah, it's here. Because you might see that at certain n, some fx is high. So it's not 0. But what I want to show you is when my n get large, what happens? You will always reach 0. At least from the picture, you need to see that. And then you need to learn how to write it down. So this is the hard part of analysis. You need to first get the concept right. Second, need to write it down. So the technical thing here is what? What is the technical thing we use here? Huh? Is the Archimedean property. If you don't have this Archimedean property, I'm not sure how you find this n. Maybe from the picture you can see, I go a bit further, you can miss it one. But how do you prove it? How to prove it? So we use Archimedean property. That is a natural number that's always greater than all the real number. So you can find this n. Otherwise, how to find this n? Makes sense? Okay, so the technical point is this Archimedean property. Got more question? More question? No? Okay. So let's look at another example. Okay. Maybe we don't go so detailed now. So let's see what's the direct example here. Hey, have I discussed what's the function here? What's the limit here? So this is the 0, 0 function at every point. -1 to 1. Okay, so you converge to 0 function. Okay, every point I prove it point-wise convergent to 0. So it is a 0 function. Does it make sense? Okay or not? So you can see that this function here converts point-wise to fx equals to 0 for all x in the domain. Okay. No question? Okay, how about second example here? What's the function it converge here? What do you think? What's the function it converge here? Huh? Where do you take 0? Where do you take 1? Uh-huh. You are telling me the sequence. What's the point-wise limit? What's the function? What's the point-wise limit? Okay, so where's the 1 point at the top? S equal to 0. Okay, so at the origin, you get 1. And then at all the other points, you get 0. Okay, so become a discontinuous function here. Okay, why? Is it obvious that when x is origin, the pointwise limit is 1? Because no matter what n, fn0 is always 1. Correct or not? Okay, but what happens if you live in this kind of region? What happens if you live in the region near 0, away from 0, a bit away from 0? Okay. Similarly, what we did just now is by Archimedean property, this 1 over n will eventually pass by the, okay. So eventually, for large n, this point near the origin will get fnx to be 0. Okay? Because eventually, this triangle will pass by the point. Does it make sense? Okay. Okay. So this is your function here. So fx equals to 1 and 0 if x equals to 0 and if x is not equal to 0. Okay. Okay. How about question 3? How about part 3? What do you think? What's the point-wise limit here? Fx equals to 1 at where? Okay, 0 to 1 and then? Good. So this will converge to function looks like it is 0, okay, when x is less than 0, and then 1 all the way from 0 to 1. Make sense? Because you can see that if you have any point near 0 on the left-hand side, this 1 over n will eventually pass by the point. Okay? Yes. Yes, this is a very important point, right? So you just need to check at this point what happened of fn at this point. No? So fn at here is what? Fn0. So what is fn0 here? Fn0 is always 1. It doesn't change. Okay. Similarly, here is the same. Fn0 is what? Always 1. Okay, what is changing is just these 2 points. Does it make sense? Question? No question? Okay. Okay, how about the last one? What happened to this? This one converged to what function? Huh? Sorry? What function it converged to? Point-wise? Hmm? Can't hear, huh? What same? Same what? What is the same? Same with what? Same with original? Can you prove it? Where do you place it? How do you define your function? This n is moving, so you want to fix. Yeah, how to fix? What's the function you want to define here? What do you mean by same? So you need to tell me what's the endpoint of this guy, right? This is 1. So what is the endpoint here? You cannot tell me n, no. N is moving, correct or not? So what's this 2n you want to put? If you put 2 and 3, doesn't work, right? 4 and 5 already run away. Okay, so what's the limit here? This limit should be 0 function. Correct or not? Because no matter what point you pick, this triangle will eventually pass by the point. It's the same Archimedean property. Okay, for any point x, there will be an n that is greater than the x. And then you just pick for all n greater than that n, the triangle will lie behind it. Does it make sense? So for any point you pick, if you pick any point further than this Fn, maybe Fn plus million, it will pass by it already, for example. Okay, if you take far enough, and this triangle will run. Does it make sense? Okay, so let me give you a concrete example. For example, 100. Okay, let's say 100 point here. If you got a triangle at, let's say, a 2 and 3, what do? Okay, you can take triangle at, say, 101 to 102. Okay, so you can find an n. Does it make sense? Okay, even if you have a triangle here, right. So let's say 99 to where? Yeah, 99 to 100, maybe like this. Okay, maybe this point is not as good. Maybe let's pick 99 to 100 have what point? 99.5, let's say. 99.5. Okay, so let me take away this. So let's say, okay, let's throw this 2 and 3 away. Let's say we have 99.5 here. We got a 99 to 100 here. Okay, so you can see that f of 99 or 99.5 is what? Is 1. Okay, but if you take f, let's say f100 of 99.5 is already 0. And then all the rest of the sequence will evaluate 99.5 to be 0. Okay, because the triangle already run away. Does it make sense? No question or not? Yeah. Hey, there's nothing tricky here. Just that you need to get the idea. Okay, nothing tricky. Okay, nothing tricky here. Okay, but so exercise here is exercise. Try write down the limit argument as in example 1. Okay, example 1. Okay, try and write this down for each cases. Okay, try and write down. I will include a full argument for one of the example, and then for the rest, try and write down yourself. Okay, no? Try and write it down, the limit argument. Any question? No? Yeah? Function 1, 0.
Zero.
Sorry?
It's not actually.
It's not actually 0. It's not. It's not 0. So where is it not 0? So F101, what happened? F101, so you can replace here by, let's say, 101, and then here is 102. So it is non-zero for the region 101 up to 102. But 99.5 is outside this region, so it's 0. Okay, no? Yeah. Okay, here, I draw it here. Okay, so it is not 0 here, but it's 0 at 99.5. Okay or not? Does it make sense? So if you put the sequence of if you put all these sequence of function together, what do you see? You will see like popping out like that. Okay, if you put them together, and then you have a line at below it, like this. 就像很多座山在一起这样 ，OK 吗？而且下面还有别人的 domain 在，别人的 codomain，别人的 image，别人的 image。Does it make sense? Okay or not? If you put all the sequence together, it looks something like this. 很多座山 Okay? Does it make sense? Yeah. Any question about this point-wise? No? Okay, so in the point-wise convergence, we observe something like this. You can converge. You can start with a continuous function, but you converge to something not continuous. Okay? So we want to discuss something that can any convergence that give me convergence of continuous function is continuous or not? Okay, so can we give this kind of convergence or not? So last time before we break, we mentioned that if this epsilon can work for all x, then convergence of continuous function should be continuous. Okay, so what does this mean? So this means that we say that so let fn be a sequence of function defined on A. Okay, we say fn converges uniformly. Okay, so this uniformly, what does it refer to? Okay, 什么东西很整齐 Okay, uniformly converges uniformly A to a function f if for every epsilon greater than 0 there exists an n such that for all n greater than n and for all x in A, fnx minus fx is less than epsilon. Okay, then we will say that f can converge to f uniformly. So what's the difference between pointwise and uniform here? Epsilon still got it. There exists and n still got on. N greater than n still got on. Also got for every x. So what's the difference between uniform convergence and pointwise? What's the difference? What's the difference? All conditions similar. What's the difference? Got difference or not actually? Where's the difference? Huh? Or can you tell me? Can you tell me what's the convergence pointwise mean? Can you recall now? The first thing I recall for you, right? What does convergence pointwise mean? Say, wait, hey, why I can't write, huh? Okay, let me put down what a pointwise convergence means. You pick a point, and then you do your epsilon business. For every epsilon, there exists an n such that for all n in greater than n, fnx minus fx is less than 0. So what's the difference here then? I already write down the two lines here. What's the difference? For all x in n, what happened? What happened to for x in n? For both cases, you have this condition, right? So what's the difference here? The order here is important, you know. Why is it important? Why is it important? Huh? One I put in the front, one I put in the middle. What's the difference? Ah, sorry? Mm-hmm. Uh-huh. For the first one, Bn. For the second one, n here depend on epsilon, also depend on x. But uniform, the n only depend on epsilon. So this epsilon will work for all x. Does it make sense? 每一个点用一个东西 ，OK， 跟每一个点都有一个 n 差不多，明白吗？ Does it make sense？ 差很多，为什么会差？你可以想象 ，you can imagine a situation for some x, this n can be very big, but for every x, there is an n. This n will work for all x. Does it make sense? Does it make sense or not? If the n only works for specific x, then you cannot get a uniform n. So the uniform here is about the n here. You can pick an n that is work for all x. Every point I just use this n enough. Okay, no. Every point I use the same n. Does it make sense? Okay, ma, uniform. Does it make sense? Okay. So let me show you. Let me show you how we use this. So immediately, which one imply which? Can you see from these two definitions? Which imply which? Uniform convergence implies pointwise convergence because you have an n that works for all x. Okay, but pointwise doesn't imply uniform because the n that you pick for all x might not work for the other x. Does it make sense? Okay, so you have uniform convergence imply pointwise convergence, but not the other way around. Okay, but not the other way around. Why am I? Okay. What's wrong? Jam. Okay, but not the other way around. Okay. Okay, let's do what? Let me see. Let's do one proof. Okay, let's do one proof. So before we take a break. For theorem, uniform convergence preserve continuity. Okay, so that means if every continuous Fn converges uniformly to F, then F is continuous at C. Okay, so let's say these continuous Fs. So we should define what is C doing here. So let Fn be continuous at C. Okay. Hey, yeah, jam. Let me see how I fix this. Okay. Yeah. So let Fn be continuous at C. Then if this Fn converges uniformly to F, then F is continuous at C. Okay. So what do you need to show? What do you need to show here? Continuous. F need to be continuous. So what does it mean? We want to show that for every epsilon greater than 0, there exists what? Exists a delta greater than 0 such that for all x minus c less than delta, fx minus fc is less than epsilon. Okay, continuity. Okay, but how do we compute this? So you need to find this delta, right? Okay, but we also know there's sequence that converge. So we can try and bound this fx minus fc by some fn. Okay, so let's say, can we split this into fx minus fnx plus fnx minus fnc plus c minus fc. Can we do this triangle inequality or not? Can, right? Okay, I just introduce fnx and fnc. Okay, but why I want to introduce this kind of inequality here? What do we know about Fn? Fn is continuous at C. So meaning there exists a delta such that this guy is less than epsilon. Okay, let's say we make it epsilon over 3. Okay, so there exists a delta for this guy. Okay, how about the third term here? Fnc minus fc. What do we know about this point here? Fn converges uniformly. So meaning what? You also can make this less than maybe epsilon over 3. Then there exists what? What do you exist here? There exists an n. Okay, such that this is true. First one, how about first one? Any difference between x and c or not? Huh? How about first one? How about first term here? Can we bound it? What is x? What is x here? How do you want this x to be? How do you want this x to be? Where I get this x from? This x should be something in the domain, right? Okay. If it's in the domain, can you apply uniform convergence or not? What is uniform convergence is? For every epsilon, there exists a n such that for all n greater than n, and for every point in A, fnx minus fx is less than epsilon. So can we apply to this x here? Huh? Can we apply x to this x here? Question. Oh, question or not? This thing should be less than epsilon over 3 using the same n here. Fair enough. This is by uniform convergence of f. This is by uniform convergence of s. Then only the middle one will give by the continuity of f n. Okay, fn. So what's the n we pick here? Actually, the n we pick here is the capital N. Okay, so we pick this capital N by picking it from the uniform convergence. And then how do we pick the delta here? We pick the delta here by the U continuity of Fn. Does it make sense? Okay or not? Does it make sense? So by uniform continuity, we will find this capital N to bound our fx minus fc. We bound this fx minus fc using this intermediate fn here. And then from the continuity of the fn, this will give the desired delta. Okay, so within this delta, okay, and then we can bound the 3 term by epsilon over 3. So if you add them out, it is bound by epsilon. Okay, is it clean or not? This proof, is this proof clean? 干净吗？学数学要有这些特质啊，要漂亮，要美丽，要干净，要严谨，这些好特质都是数学的，不是整天难，明白吗？数学是干净、美丽、漂亮、简洁，不是难。谁在想数学难，就把100拔回去，是不是？对吗？这些好特质都没有学，整天只讲数学难，我也不知道他来学什么数学。你明白吗？不是，可以吗？ Can follow or not? Can everyone follow this proof? Okay, from uniform convergence, I found this capital N. Once I found this capital N, I can use triangle inequality, bound this term by 3 terms. And then, how do I find delta? So the delta comes from the continuity of F capital N. This question. Yes.
They are the same N.
Yes. You mean different capital N? So what N can you pick? No need maximum. There's exists one N already, right? So for all the N greater than capital N, you can make sure the first and last term less than epsilon over 3. So what can you do? You can pick N plus 1 or N plus 2, N plus 3, N plus 4 also works. So all the small n greater than capital N all works. Not necessarily big N. Does it make sense? Does it make sense? Oh, what's your question? You ask again. Maybe I understand wrong. 你讲华文的，I mean 你可以讲华文吧？你要知道我们是要 训练英文的。So yeah，继续。
可能这个可能一个它会被一个 N1 对，
嗯对
最后一个可能
对。So my question is, this N1 N2 is the same or not? From what we discussed from uniform convergence, this N depend on X or depend on epsilon? Depend on epsilon only. So no matter what X, the N is the same. So there's no N1 N2. N1 is equal to N2 in this case. Does it make sense? It's the same N that works. But no, not uniform convergence. Just now we just discussed. This N depend on X or not? Doesn't depend on X. Only depend on how you choose epsilon. I choose my epsilon to be epsilon over 3. Then it will give, by uniform continuity convergence, it will give me an N. And then this N will work for all points. No matter it's X, no matter it's C, anything inside my domain. Correct or not? So no need to worry about N1, N2 because it's the same and that works. This is the good thing given by the uniform convergence. N only depend on epsilon. Okay, so you don't need to pick maximum or what because you only get one N. And then my point is, if you don't want to pick this N, what other N you can pick? Can you pick other capital N or not? Huh? What can you pick? N plus 1 or N plus 2, N plus 3, N plus 4, because it is still less than epsilon over 3. Okay, if for all the small n greater than n. Okay, yeah. Any question? Question? Yes. Yeah. Or we fixed an n already. Yes. So where does big N from? From the uniform convergence. Does it make sense? Just now we are working so this part is working so we are trying to see how we fix it. So this part is just working it's not proved yet. So proof you need to write down step by step. So how to write down step by step? By uniform convergence, you can find this capital N here. And then you can bound fx minus fc using this 3 terms here. So we can bound the first term and the last term by, say, epsilon over 3, okay, using uniform convergence. But the middle here, how to bound it? How to bound fnx minus fnc here? How to bound this point here? So you use continuity of fn. Because every n, every small n, fn is continuous. Then this you can make this difference less than epsilon over 3 as well. Okay, there's just a delta such that this would. So you need to pick this delta that would. Okay, you note that this delta, the delta here fixed where you pick x on. It doesn't affect the first term and last term, right? Because the uniform convergence happen everywhere. But now the delta restrict your x. That's fine. But my uniform convergence still happen everywhere. Okay or not? No question? Any question? 有问题吗？没问题。Okay. Okay, so this part is working 这只是草稿所以你要写一个 proper proof，就是有什么条件，有了 n，我才可以包了过后还有什么 continuity， 才有这个 delta。OK 吗？ Yeah. So just now we are just trying to guess what is the n I want, what is the delta I want. So I need to start from the last inequality there. Okay or not? Yeah. Okay. So let's take a break until 1:27, and then we will come back with an example how to show uniform convergence. By the way, I have returned your assignment already. Have you guys read your mark assignment? Okay, so maybe if we have time later, we'll discuss. I found out the students here don't like to how to say argue marks. 知道什么是 argue marks 吗？讨分，OK，也不要讲到讨分啊，哈，你们也不是乞丐，对不对？但是问题是，如果是你的，你就要问，OK，不是你的，OK，不知道为什么被扣分，你也要问，OK，不然你就不会学到东西，明白吗？不要马路，也不要害羞，Does it make sense？一分很好的学生啊，问他为什么你不要问一下你老师这么扣你分，他也讲不出来哦，我也不知道为什么。So 你们一定要问，OK？是你的更要问，OK？不是你的也要问一下为什么被扣分。如果你错了，就问一下到底错在哪里哦，OK 了，这样你才会学到东西，明白？OK？ So later we'll discuss marks, and then if you see I miss mark or what, then you can ask me. OK？ Seng. Right. So I write down this sequence of function here. Okay, we have nx cubed over 1 plus nx squared. Okay, so the question is, what does this sequence converge uniformly to? Okay, so what's the guess? So how to guess? If you want to check point wise, if you want to check point wise, do you know where this converge to? If you check point wise, what is the limit? What's the point wise limit here? Although I'm using different word, but what is the calculation you need to do here? Is the calculus one that calculation? Okay, so how do you compute? Divide n, right? Okay, so you get s cubed over 1 over n plus x squared. But what do you get here? You get x. Okay, so if you go and plot your GeoGebra, what does it look like? if you plot out the GeoGebra, it looks like this. Okay, so the first term of the sequence is this green line here. So you can see that this sequence of function approaching to this purple line here. Okay, so what's the property of the purple line here? This line is almost y equals to x. You see, when it is -1, it is -1. When it is 1, it is 1. Okay, when it is x equals to -1, the y is also equal to -1. When x equals to 1, y is also equals to 1. Almost y equals to x. Okay, even though here there's some how to say stagnant, you see, close to 0 is stagnant, but the stagnant part is getting smaller and smaller. Can you imagine or not? Ever imagine? Okay, ever imagine? Okay, you see the stagnant part here is getting shorter, shorter, and shorter. Okay, so eventually you will get the linear graph. Does it make sense? Okay, okay, make sense? Okay. Okay, so we need to show. So how to show? So we need to show that plane Fn converge to Fx equals to x uniformly. Okay. So we want to show for uniformly. What do you need to do? What's the first thing we need to do? Fix epsilon. Good. So let epsilon greater than 0. Okay, we want to find n that works for all. So how to find this n? So how to choose? No idea. Actually, no idea to choose because we need to get from what we want. Okay, so actually what we want fnx minus fx is less than epsilon. But what is the general fnx? We get Sn cubed over 1 plus nx squared. So this is the definition. Okay, and then we want to make sure that this thing is less than epsilon. But what's the difference here? What's the difference here? If I quickly compute it out, can you follow or not? So I get this calculation here. Can follow this calculation? You get your denominator equal. Can follow this calculation? Can or not? Can follow? Everyone? Can follow or not this calculation? Just expand the denominator and then add them up. Okay? Okay, but how to bound this term? You see the n is inside there, correct or not? I want to make this less than epsilon. Okay, the n is inside there. How to extract it out? So the claim here is I will use the fact that for all real number in R, a squared plus b squared is greater or equals to 2ab. Okay. Is everyone agree this is true or not? Hey, have we proved this? How to prove this? This is equivalent to a minus b squared is greater or equal to 0. Okay. So how to use this? So I will replace my denominator by 2 times the actual value of x times square root n. Okay, so this is how I use this inequality here. Can follow? So you regard this 2 as a squared plus b squared. But it is in the denominator, so the inequality solved. So in this case here is good. Why is it good? Because I'm left with something that is 1 over 2 square root n. So as long as I make this number less than epsilon, then we are good. So how to make this epsilon less than epsilon? So I need to pick n greater than 1 over, you tell me, how should I pick my n? 1 greater than, n greater than 1 over how to make sure this last inequality here true. 4 epsilon squared, good. Okay, which is equal to 2 epsilon. So if my n is greater than this capital N, and for all the points in my domain, then this will work. Okay, so I have found an n that works for all x. Okay, so this n only depend on epsilon. Okay, how do I choose this n? I make sure this n is greater than 1 over 4 epsilon squared. Does it make sense? So this n only depend on epsilon, and then it works for all x. Why? Because in the calculation, the x already disappeared. Gone. Okay. Does it make sense? Okay, no. 有问题吗? Any question? Any question? Okay. Okay, so in general, is it still copying or can we move on? In general, how do you see uniform convergence? Is it still copying? Jinsen, you still copy or Jinsen, are you still copying? No? Okay. So in general, how do you think of this uniform convergence? So you can think of it as the left picture here. Let epsilon greater than 0, then Fn converge uniformly if there exists an n in n such that for all k greater than n or Fn or n greater than n, Fn lies entirely inside the epsilon region. Okay, so for all epsilon, you can see that all the sequence lie inside this region. If it doesn't converge uniformly, what does it mean? That exists an epsilon greater than 0 such that for every n, there exists some k greater than n such that fk doesn't lie entirely inside the epsilon region. Okay, there might be some point outside the epsilon region. Remember, in the uniform convergence, you need the epsilon to work for all the x. So if it is working for all the x, then your function will lie entirely inside the epsilon region. If it doesn't hold for all x, maybe some x go outside the epsilon region. Does that make sense? Question? Question? Any question? Which one? On the right hand. Yes, for all, because this epsilon is random. So it is for all. It is for all. Because this is random. Let x epsilon greater than 0. Okay. It's random. Okay. So if you have uniform convergence, all your Fn after certain big N will lie inside this region. If it doesn't, then maybe some part of the function will go outside the epsilon region. Okay. Okay. So that's why we look for this uniform convergence to talk about continuity. Okay. Otherwise, you could imagine last time we had an example, right? X to the power n. X to the power n like this. Converge to what? Converge to a function that has 0 and then 1 at the endpoint. Okay. Yeah, because if you put an epsilon region around 0 function, you will see that the function always go outside this epsilon region. Okay, so it doesn't converge uniformly. You only converge pointwise. Okay, no? Does it make sense? Okay, so for one epsilon, you need to work for all n and all x after a certain n. After a certain n, every sequence need to lie inside this, wholly lie inside this epsilon region. Does it make sense? Okay or no? Seng 看得懂吗？Seng 什么？慢消化？听懂我前面讲的东西，也要从这幅图听懂我之前要讲什么，懂什么意思吗？会不会很悬？悬就对了啊，考试更悬了。对，多做一点练习，OK 吗？不要先听懂先不要想考试这样重要，先听懂，我们再解决考试的问题，一个一个解决，不要本末倒置。我们不是为了考试啊，OK，先懂先，然后我们再想怎样解决考试的问题。啊，不懂的话，解决考试问题也没有用，对吗？看得到什么差别吗？适应有看到差别吗？啊，什么差别？你不要跟我讲 a b s 你现在跟我讲一些比较实际的东西，有看到差别吗？啊，一个凸出来嘛，一个在里面嘛，所以从哪里凸出来，躲在什么里面，这个要知道，就是那个蓝蓝色的点，那蓝蓝色的点是什么？是一个 epsilon region 来的。所以如果有 uniform convergence，我就会保证所有的 function 躲在 epsilon 里面。但是呢，如果没有 uniform convergence 呢，有些点就会跑出来，就这样吧。然后再去理解，OK，怎么写，怎么 prove，一个一个做，OK，一步一步做，可以吗？OK，any question？ Yeah, right. So, what time is it? So there are some property that we can check. So, so what do we have? So for example, what we have gone through here. So if I will assume Fk has the following property, let's say we have gone through continuous, you can ask if Fk converge to F pointwise, is F continuous or not? Continuous or not? Do you think? Not necessary, right? We have the example already. The y is x to the power n example. Correct or not? Okay. But if Fk converge to F uniformly, must F continuous or not? Yes, right. Because just now we just prove it, right? Okay, we just prove it just now. Yes. So similarly, you can check for other property. For example, if every sequence bounded, okay, if it has a pointwise limit, does the pointwise limit function need to be bounded or not? Or the uniform limit have to be bounded or not? Similarly, unbounded. Uniform convergence, differentiability, integrability. Okay, what do you think? What do you think? Sorry, bounded. For bounded, has to be true? Sorry, say again. So I mean, so yes or no? Yes for which one? For both? For both. For both. You say so? Uh, Actually, it is not true for pointwise. Okay. So if it's not true, can you come up with one example? Or not? Meaning what? You have bounded function, but when you consider the limit, that function is unbounded. Can you give such example? Or not? Any unbounded function in your mind or not? Oh, I think there's a very easy unbounded function, right? The first unbounded function you see in your life, I think is in your life. Huh? Nx, you mean sequence of nx? So what I want is, can you suggest an unbounded function? Okay, unbounded function, and then we can create a sequence of bounded function. Okay, so what's the easy unbounded function in a finite domain? If nx, then if x, then the domain is increasing. It's okay actually, but how about consider this function here, 0 to 1. Can you construct sequence of function that converge to this function here? Yeah. Can you construct a sequence of function that converge to this function here? Can or not? Does this help? Any idea how to construct a sequence of function that converge to this function here? Sorry? Many lines? How to make many lines? So can I define a sequence like this? Fnx equals to 1 over x. Okay. If your point is all the way from 1 over n to 1, and then I kill it for the rest of the point. Does it make sense? Can everyone see this sequence here? What this sequence is doing? When n increase, what happened? This point will move forward to 0. And then the region of 0 here will become shorter, shorter, and shorter. But what happens here? How does this part grow? This grow like 1 over x. Does it make sense? Can or not? Question? Got question? Got question? Any question? Got question? Why is it bounded? I mean, where's the domain I consider here? Only 1 over n to 1. So what is the, so we have a theorem, right? If you are a continuous function on a closed interval, you must achieve maximum and minimum. So it's bounded. But if you substitute all the point inside 1 over n to 1 in here, is it bounded or not? Is it finite? Finite or not? Oh, I mean, the point is not finite, obviously, but is the value of f finite or not? If I just substitute x to be 1 over n to 1. Yes, right. Okay. Why is it unbounded in that case? Because when x approach 0, the value increase. But here the value I take here is just 1 over n out to 1. Okay. No? Also, you can use the theorem, right? Extreme value theorem. If you are continuous at a bounded interval, you must achieve maximum and minimum. So bounded. Okay. Yeah. Why is unbounded here? Because this is not a closed interval, so you cannot use extreme value theorem. And then you can see that when x approach 0, fx approach infinity. So you need to show. Okay. Yeah. Okay. So depend on what domain you take. Domain very important. Domain is very important. Okay. So for the bounded case, I think we leave as an exercise here. Okay. I think we don't prove it. Leave as an exercise. I will provide the proof. It's a very how to say good exercise to prove whether you can use uniform convergence or not. And then unbounded case is no as well, and yes. Okay, so for these two, we will put into tutorial. Okay, for uniform convergence, for uniform continuity, um, is the first answer is no. Okay, why no? For point wise, it's already not continuous already. How can it be uniformly continuous? Okay, so same example you can use. But for uniform convergence, it is yes. Okay, it is yes. Okay, so you can prove it. This one also left as a tutorial question. Okay, and then left with this differentiability. I think, let me see, should we deal with this differentiability? Yeah, uh, I think we can deal with it. So for both cases is no. Okay, surprisingly no. Surprisingly no. I think there's one reason I can give to it. Because when we discuss differentiability, we are discussing about the secant function, not the f itself. So surprisingly, the convergence of f and x doesn't talk about the convergence of f prime and x. Does it make sense? You can make f and x and fx very close, but can you make the two secant functions very close or not? That is a different question. Okay. But under certain condition, you can deduce differentiability. Okay, but in general, you can't. Okay, and then for integrability, is no and yes. Okay, so if you have uniform convergence, then it is integrable for your uniform limit. So let me see which one we do the proof. I think we will discuss four of these. And so we will discuss four of these. Okay. Any question or not? Any question? We'll discuss four of these. Okay, the one I left with tutorial is quite how to say, it's very good exercise to see if you know all the separate concept and then how to put them together. Okay, any question about this table here? 有问题吗？理解这个 table 要讲什么吗？不用讲 proof 不用紧，但是你要至少了解这个 table 要讲什么先。Yes, yeah, yeah, yeah. Why 都是 no? Bounded 我们给了 counter example, right? Pointwise convergence 但是 unbounded。So unbounded 的话就要给 counter example 咯。Unbounded 的东西 converge to 一个 bounded 的东西，要给 counter example。bounded converge to unbounded 的东西，然后 unbounded 的话是 unbounded converge to bounded 的东西。给 counter example。我早上想是 no 啊，我有一个 counter example 忘记了，我要写下来，我还没有写下来。什么不可理喻的，不可澄清，不明白。不明白这个 table 怎样用啊？就是 FK 的 term in FK 每一个都是 continuous 的，它 converge point wise 去 F 要 continuous 嘛？你看那个字，看字啊！你讲的时候要看字啊，不要听人家讲啊，这是这里学生的问题，因为你只听人家讲，你没有看字，你没有看 definition 的，人家跟你讲什么你就信吧。OK OK，不要信我，信这个字，看我讲的跟这个字匹配了。OK，不匹配我们回来。为什么？因为学生每次问老师你要什么，你要什么，不可以的。我们有 law 的，我们要跑 law。OK，我们全部人要跟着 law 跑，不是跟着老师的喜好。OK 吗？跟着 law 跑。所以看这 law，看我解释的合理吗？OK。So 第一 assume that FK has the property， 所以每一个 FK 都要有这些 property。然后你要 ask 问一个 question， 如果 if FK converge to F point wise must F satisfy these property 呢？所以说如果FK 每一个都 continuous，and then F point wise converge to 一个 limit 一个 function， 然后我可以问一个问题嘛？这个 function 也 continuous 吗？OK， 不一定。好，我们不一定，我 prove 了，我们给 counter example 了嘛。下一个 bounded 呢？如果每一个都 bounded，它 convert 去的那个东西要不要 bounded？要不要？不一定哦，刚才我们给 example 了。OK，unbounded 呢？我 claim 是也不一定，可能你 unbounded 会 convert to something bounded。我的 claim。unbounded 可以到，我觉得也是用类似的 example 啊，只是你反方向做吧，对吗？反方向做嘛，对不对？合不合理？来，我们来玩，数学就是要拿来玩的。OK，不要跟着死跟。数学要拿来玩，我想用同一个 example 合理吗？unbounded 可不可以做一个 unbounded 的 sequence 出来？Instead of 我切前面，我怎么不要把后面切掉呢？懂什么意思吗？为什么我不要把后面切掉？为什么我不要 consider 这样的 sequence？来，我画给你看。应该要用一减有n 加一这样，可不可以玩这样的东西？Let me think。这个不太 work 哦。 应该要用1 over n，可以吗？可以玩这个吗？哦，这个是什么 fn？来讨论一下，这是什么 fn？If x is in between 0 and 1 over n，我让它是1 over x，给它 unbounded。但是呢，after 1 over n，我把它杀掉，合理吗？这个东西是不是应该要 convert 去convert 去 f(x) equals to 0 for x in 0和1，是不是要不要？要吗？要吗？问问题，哪一个不明白要问？来 convert 吗？看啊，1 over n 越来越小，越来越小，越来越小，越来越靠近零，等这一段零就越来越长，越来越长哦。那个 unbounded 的 part 呢，就越来越短，越来越短。虽然还是 unbounded，但是它还是越来越短，越来越短，越来越短。这样的 point wise，但是我们只考虑 fix 一个点嘛。你 fix 每一个点啊，away from 零啊，我都可以让这段零的 part cover 它。为什么？那什么 technical point 在这边 ？RKB over 1 over n，你肯定能够找一个1 over n 小的云了。OK 了，可以吗？可以想象吗？可以想象这个 sequence of function 在做吗？诗音可以想象吗？你一定要想象，你没有想象啊，你就是学不会的。你不能够看这样多 n 这样多 epsilon 这样多 delta 看不懂。我们制造这些 epsilon 的语言，就是为了我们要想象它嘛。你要先想象到先，看得到吗？看到这个 sequence 在做我们，看到吗？看到它 f1 f2 f3 f4会发生什么事情吗？告诉我现在发生什么事情？Sorry，什么东西越来越这样啊？1 over n 会怎样？哦，当 n 变大的时候会发生什么事情？越来越小哦，所以这一个 part 会发生什么事情？越来越长哦，连上面那一段呢就会越来越短哦。但是它虽然越来越短啊，它还是每一段都是冲去 infinity 的，每一段都是冲上去的，对不对？但是它会越来越，它冲上去的那个 part 会越来越小。OK 了，OK 啊，所以 for every x，只要你没有动到零，OK，在一之间，你都会有机会，你都是 limit 去零。OK，does it make sense？OK 吗？有问题吗？没问题啊。先要懂先，懂了你才懂要写什么啊。如果你不懂，你就要懂要写，这个就本末倒置了。OK，你要先懂先，懂了就大概就会写，你不会错到哪里去的，真的。OK，但是你不懂啊，你写出来的东西啊，很容易就会错，OK，很容易会错。OK 了，可以吗？可以理解吗？OK 啊，Yeah，So yeah，the rest 我们就 tutorial 见，对，我们 discuss 4个 case。OK，我们 discuss 4个 case。So what should we discuss now? Okay, let's discuss about differentiability. 我觉得我们 discuss 一个，我们可以 break 一下。So point-wise convergence and uniform convergence doesn't preserve differentiability. Differentiability. Okay, So, what's the first thing you saw that is not differentiable? 我这个人是蛮结果论的，所以我喜欢从后面来。OK，没有，从后面讨论。OK，从后面讨论。OK，从后面讨论怎么讨论？我们从它的 limit 先讨论，不 differentiable 的 function 来讨论。OK，so 什么 function 不 differentiable 啊？啊，画出来了，f(x) equals to modulus x。Why is it not differentiable？跑回去前两课的东西。左边的 gradient 是什么？按照算，右边的 gradient 是什么 ？1。所以他们取 limit，一边是减一，一边是一，不会等于在零点那什么？每一个 part 都 differentiable，但是零点那个 part 不 differentiable。当然，我们可以拿一堆的 sequence，OK，、你可以想象，OK，要怎么想象呢？要怎么想象？So let me think. First term，我看一下，我看一下这个 sequence 是什么。Okay, good. So what can you think? So how to converge this to this function here? So for example, let's say the first term we take is y equals to x squared. Okay. And then the next term we take, for example, y equals to x to the 4 over 3. So how does this graph look like? So this graph maybe looks like this, sharper a bit. Okay, sharper a bit. And then the next term, maybe we can take x to the 6 over 5. Okay, so can you observe what's the similarity over these 3 points here? They are all even, first of all. Even. And then second, the power there is doing what? Is converging to 1. Is converging to 1. Agree or not? Agree? 4除3是什么？1点什么东西？1.333。5除6呢？啊，1.2哦，靠近1了，是不是？猜一下下一个要放的 power 是什么？猜一下下一个可以放的 power 是什么？猜一下下一个，跟着这两个 criteria 走，下一个是什么？要 even，然后要靠近1。下一个246了嘛？下一个呢？8哦，8除几？最靠近了，是不是更靠近1了？8除7等于2，计算机拿出来。1.1哦，越来越近，越来越近啊。So we can write down this formula actually. 啊，有没有人要猜这个 formula 是什么？y 等于 so f(x) equals to x to the 1 plus 1 over 2n minus 1。这个 formula，OK，会送出这些 sequence 出来。Does it make sense? OK 啊，OK，OK， good. So the claim is 这个 graph 啊会 converge to 这个 absolute value of x。OK，怎么 show 啊？怎么 show 这个东西？ we can rewrite the sequence of a function here x times x to the 1 over 2n minus 1. Okay. If we rewrite in this case, how do you compare these two functions here? We got an x here. Okay. We also got 2x here actually, but we only have 1x here. So what to do here? What should we do here? So what we really don't know is what about this part here? Okay. When n get large, this part stand still. But what about this part here? Okay, what happened to this limit here? So I'm asking about what's the limit of x to the 1 over 2n minus 1. So we want to check point-wise first. Let's check point-wise first. So if we check point-wise, from this solution here suggests that we should look at it in 3 ways. What are the 3 ways? It's easy to see it in 3 ways. If x is from 0 to 1, if x is in -1 to 0, and then if x is equal to 0. Okay. So one of them is easy to see. Which one is easy to see? X equals 0 because no matter what n you put, it is always 0. But what about the other two? How to understand the other two? First one is 1. Why? Sorry, positive x, and then almost to 0. Oh, okay. Okay, good point. Okay, good point. So you say that this is 1, is it? Because when n grow, the power is almost 0. Okay, there's a good way to see it. How about the second one? Why? Because it's minus. Huh? Why not 1? I mean, you put minus inside here, this one go to 0. But the answer have to be -1 somehow. But why? Of course, you have to go back to the limit definition. So for every epsilon, there is this what? There is this delta such that what? Such that hmm, let me see how to put this. Such that how to put this? Such that if x is less than delta, then x over 2n minus 1 is less than delta for x in the region 0. Okay, this one is for the first part here. Okay, is this true or not? Let me see. For every epsilon, x then there's this delta such that delta is less than x, then it's true. Okay. Yeah. Is this the limit definition or not? Check if this is the limit definition or not. If you want to show this limit is equal to 1, is this the limit definition? The difference between these two is less than epsilon, right? Okay, but how does the delta works? Huh? Does it make sense or not? Sense? The delta looks a bit weird. Why does it look so weird? Let me think. Why does it look weird here? Is this delta correct or not? Bit weird. Yeah, question. Hello, come on. Ultraman. delta 这个肯定是错的，这个是 epsilon 来的。But this part 呢？ This part, how do you realize this? X to the some power, how do we define this? Actually, we define using the exponential function, correct? So we can rewrite this difference here by e to the 1 over 2n minus 1 ln x minus. We can rewrite using exponential.
I'm looking for the limit x is in 0 to 1. What is the limit of this function? But the limit, the pointwise limit.
The pointwise limit, yes. Let me think. Okay. So, I mean, we need to fix this one first, right? I think that's right. I'm trying to mix the continuity with this thing already. So we need to find that for every epsilon that exists an n, right? Such that for all n greater than n, then this is true. Yeah. Okay, I think this is right. Okay. Yeah, but okay, I remember why I want to bring the delta in now. Because to pick this n, we need the delta. Okay, to pick this n, we need the delta. Why do we need the delta? You see, if we want to make this less than epsilon, what is this asking actually? This one actually asking for the continuity of this part here. Continuity of E. At what point? At 0 point. Okay. Does it make sense or not? Continuity of E can solve this problem. Okay, but we know that E is continuous at 0. Okay, so this means what? Since e to the y is continuous at y equals 0, then there exists a delta such that for all k, okay, let's use n. For all n with ln x over 2n minus 1 less than delta, we will get this inequality here. Okay, so this continuity okay, this continuity here gives us the delta that tell us what n will work here. So what's the n that we can pick here in this case? So we can choose what? Choose n to be half times delta over ln x plus 1. Does it make sense? 合理吗？不合理，看不懂。Okay, so what do we need to show? Okay, first of all, we want to show the pointwise convergence here, right? Okay, we show for the first case here. So we fix our x in this 0 to 1 point first. Okay, And then we want to show that for every epsilon, we can find a delta such that, for every epsilon, there's an n such that for all the small n greater than capital N, this inequalities here holds. Make sense or not up to here? But what's this inequalities here? How do we define x to the rational power? We actually use exponential power. Remember in the tutorial 8. Okay. But if you write this form, what does this mean? What is this? If you want to make this less than epsilon, what is this? What's the difference here? This is the what? Continuity of E. Okay. Continuity of E at where? At what point? At the point 0. One of the points 0. This point is changing. Okay. So at this point it is 0. But what? But there exists, if EY is continuous at y0, what does it mean? There exists a delta such that this point minus this point less than delta, you will get the inequality you want. So in this case here, can you make this value less than delta or no? Can or not? With x fixed already. X is fixed already. Okay, but can you still make this less than delta or no? Increase the n. So this will determine how you pick the n. So you need to pick the n like this. Okay, so that for all the n greater or equals to n, you will get that the inequality that you want. Does it make sense? Okay or not? Question? Yes. Yeah, Pn. Yes. On x over delta. So how do you rearrange this guy? How do you rearrange this? You see, because ln x is positive or negative? Ln x can be negative, is it? Because our x is from 0 to 1. What happened to our ln from 0 to 1? All negative. Negative? Negative. Okay, so that means we still need to keep our modulus there. We want to throw away the negativity, but the bottom is always positive. And then, so to get this true, we need to get 2n minus 1 greater than delta over absolute ln x. Okay, so we need absolute here. And then you will get the inequality that I put here. I mean the equality. Does it make sense? Why delta over ln x? I want to get this inequality. So this inequality is equivalent to this inequality here. The ballet 在哪里 ln x 跟 delta. Let me think. Oh, okay. Thank you. So you get ln x over delta, is it? Okay, yeah. That's right. Yep, that's right. Correct. Yep. Okay. Yep. Okay. So you need to make sure your n is large enough so that you can control this term within delta. Okay, now. So we are putting quite a few things together. Yes. 没有 OK 前面改哪里？第二行，这个要丢掉。OK， 直接进来。OK， Yep， 可以，没有错。Correct， 对 ，Yep。OK So similarly for this case, this case is similar. Okay, why do I say that this case is similar? Instead, what do you consider here? So for points, okay, so for points in -1 to 0, what is x to the 1 over 2k minus 1? What is this? This is just minus absolute value of x to the 1 over 2k minus 1. And then what is this? This is minus e to the 1 over 2k minus 1 ln absolute value of x. Okay, so you go back to the discussion of what we have discussed just now. So this guy should converge to where? So from the discussion just now, this guy should converge to -1. Okay, no? Does it make sense? For all the point in the negative part, I write in this form, minus of a positive to this power. But this part is what we have discussed just now. This function converge to 1. So minus of that function should converge to -1. This is the limit of continuous function. Does it make sense? Limit of product of continuous function. So you can think of it as -1 times e to this guy. Okay, so we know that the e part converges to 1. The negative one obviously converges to -1. So the product of the two limits I get -1. Does it make sense? By using the limit law for the other part. Okay, and using limit law. Make sense or not? Okay. Hey, this one we show it for point wise. Actually, the exponential function on this what is this domain here? From -1 to 1 is uniformly continuous. So the epsilon we use can work for all points actually. So the limit here can also work for all x. Okay. So this example includes pointwise convergence and uniform convergence. Okay. Pointwise convergence of differentiable function might not be differentiable. Uniform convergence of differentiable function might not be differentiable. Cannot. Does it make sense? Okay. Yeah. What I want to say is this for every x here, we can really move it in. Okay, move inside here. Okay. You don't need to fix x first. We can also put it in. Yeah. Maybe I'll write down in detail so that you can have a look. But in the class, you need to get the idea right first, get the concept right first, and then go back and then write in detail. Okay, I will write in detail in the lecture notes. Does it make sense? Okay. Okay. Okay, what time is it? 2:26. Let's break for 4 minutes and then we can discuss tutorial. Assignment. Assignment solution. Yes, what?
n 值被的你的标
我的 delta 也是 based on我的 delta based on epsilon 也 based on x。in 这个 case， 你说这个 case 啊 ？Yeah, based on epsilon and based on x。我先 fix x， 然后再 fix epsilon， 然后再选一个 delta。但是我最后 claim 的是，我最后 claim 的是这个 n 到最后不会 depend on x。这是我最后的 claim， 我还没有 show 给你看。我 show 给你看的是 depend on x，depend on epsilon， 所以只有 point wise 了。但是我最后 claim 的是你可以把它变成 uniform。所以怎么变成 uniform 呢？先不要管 x 先不要管 x， 先只有 epsilon 在你的脑袋吧，你就要开始导 n 了。OK， 但是呢，但是就是这个 delta 它会 works for all x。 work for all x 跟all work for all，sorry 不是讲 work for all x，就 work for 所有符合这个条件的，只要符合这个条件，小于 delta 就可以 work 了。所以现在是什么情况？所以现在的情况是，let me think，有没有可能有一个 n 可以 work for all x 跟 epsilon？想一下，我想想，我们讲这个东西有没有必须是work for 全部的。为什么我们一定有一个 delta 的 work for 所有符合这个点的东西都可以成立这个 epsilon？所以我现在要 make sure 的是，现在 make sure 什么？我要 make sure 是 there exists there exists 一个 n such that 所有的 x 跟所有 n 符合这个条件呢都可以 work。想一下，我选了一个 n 过后，所有的 x 都要 work。选了一个 n 过后，所有的 x 都要 work。这样的话，取决于我的 x 是谁啊 x 想一下，我的 x 啊，n 就 depend on x。没有，我要选一个 n subject 所有的 x 都要 work。有可能吗？可能的啊，non x 哦，从零到一是很忙的。想一下，我之前想是 EY 是 uniformly continuous，想一下，哦，OK，想一下，so try and think whether or exercise and converge to F uniformly or not。还是因为这个我们只有一个 part 罢了，对不对？我们这个只是这一个 part 罢了。Maybe it doesn't converge to this uniformly, but the whole thing will converge to absolute x uniformly. Maybe. Let me try. Let me try. Because previously I thought this will converge uniformly to these three things also. This three piecewise function. This piecewise function. Seems like not. Seems like not. Because if you fix an n here, you're not sure whether this ln x will be small enough or not. Because this ln x depend on x. this x can be very nasty. If you get closer to 0, it get really, really large. Okay. Yeah, let's think about it. I think maybe this function doesn't converge uniformly, but what we can try and check is maybe this will converge uniformly altogether. Okay, no? Does it make sense? Okay, I'm trying. If I can make it tomorrow, then I'll let you know. Okay, can or not? Can I understand what we need to do? Okay, yeah. Okay, we'll think about it. So everyone agree, this point-wise convergence, agree or not, everyone? Okay, if you have point-wise convergence here, then you can multiply x together. So the first part you will get x, second part you get minus x, and then you get 0. And then once this thing together, this is exactly the modulus function. Okay, if you multiply with x. Yeah. So our claim here is maybe this convergence is not uniform, but if you multiply with x, you hopefully can get a uniform convergence. Okay? Yeah, uniform convergence at whole, not at the pieces. Okay, we will try this. Okay, let's try this. Okay, so let's discuss assignment. Actually, I think your assignment is doing quite well. Okay, especially Sydney. Sydney, your solution. I think you have more thinking now. Okay, instead of just writing, working. Do you think yourself, or you refer something and then you think about it? Can you hear it? You what? Refer something, but I can see your own writing. Okay, so it's very good. Although maybe it's not accurate, but I can see you have some, how to say, your own logic there, which is very good. Okay, so keep it up. All right, so the first question here is to prove that this function is continuous at x equals 0. So why are we asking you to prove this? Because if you can see, we define this function piecewise. So it's not clear whether they are connected or not. Not clear they are connected or not. So to show this function is continuous, what do you need to show? Left and right limit is the same and equal to the value at x equals 0. So the strategy here is I want you to know this bound. Okay? But the question is about 1 over x. But I only tell you how to bound x. Okay? So are they related or not? Are they related or not? They are related, right? You simply substitute x to be 1 over x. Okay. If you think about 1 over x here, what is this number is doing? Huh? Sorry? X. Okay, if you forget the floor function, it's just x. Okay, but if you put the floor function back, what does it mean? 1 over x, you take the floor, meaning you take the smaller, right? Smaller. Then you invert it again and become bigger. Become bigger a bit. Then become bigger a bit. So how do you do this? So why I give you this inequality here? Because I want you to use squeeze theorem here. Okay, because if you know that the two function that you squeeze by is having limit to 0, then you will know that fx also take limit to 0. Okay. So is it clear that yx and x over 1 over x take limit to 0? Clear? Okay, these two are continuous at 0 first of all. Okay, and then I think it's clear that this limit is 0 for x, but x over 1 minus x, can you rewrite it or not? Here we write this function. Here we write this function of x, for example, x minus 1 plus 1, like this. And then what is this? Minus 1 plus 1 over 1 minus x. Okay, so we know how to compute the limit for minus 1. We know how to compute the limit for 1 over 1 minus x. Okay, so by limit law, we get minus 1 plus 1. So it's 0. Okay. Yeah. Otherwise, you need to prove why x over 1 minus x have limit 0. Okay, otherwise you can use what we already know. This one should be clear why we get 0, right? How to make this less than absolute. Okay, right. So for the second part, everyone actually do well, but just I want to catch your reasoning. I want to catch your reasoning. Why you want it to be continuous? Why you want it to be differentiable? Of course, the question want you to be differentiable, but how do you link to continuous? A lot of you just say to ensure continuity, differentiability, then I want this limit to be true, to be true. So why need continuous? And question only asks about differentiable. Answer me. Why? Why do you need continuity? The question just asks for differentiability. Sorry? For the second function? No. And the question only asks for differentiability or why you need to check continuity. Yes, so differentiability implies continuity. So if you only check for differentiability but you don't ensure continuity, then cannot be happening, right? Because if this function differentiable, it must be continuous. So that's why you need to check continuity also. Okay, so you need to write down this argument. Otherwise, why I want to check continuity? Can don't check or not? Can or not? Can I not check continuity or not? Cannot. The answer is cannot. Why cannot? Why cannot? Because differentiability implies continuity. So if you want continuity, if you want differentiability, continuity must be there. So you need to check both. Does it make sense? Okay. Yeah. You know how to check, but you don't know how to put the argument together. So this is the problem. Okay, this is the problem of people doing maths here. You know what you need to do, but you don't know why you need to do that. So that's why the pure maths are in this school very weak. This is the problem. You don't know why you want to do it. You just know how to do it. Okay or not? So you need to ask why. Why I need continuity? Can I put continuity away? Can or not? Cannot. Because differentiability implies continuity. If you are differentiable, you have to be continuous. Otherwise, doesn't work. Not continuous, then not differentiable already. No need to discuss anymore. Okay, good. For the question 3, I think everyone do it well. But some of you, is it you just copy the chain rule? I mean, not copy lah. You modify the chain rule proof inside the lecture note because you guys also use the auxiliary function, right or not? But this part here don't need to require the auxiliary function here. Why? Because we already assume that fx is greater than 0. So you don't need to worry about the denominator getting cancelled. What's happening in this denominator here? Inside here is positive. Square root of a positive number still positive. So positive number plus positive number should be positive. So you don't need to worry about cancelling. In the chain rule proof, you need to worry about cancelling because we consider general function. They might cancel. But in our case, no need. Okay, but I didn't penalize you. I think few of you, Kwan Ye, you are one of them, right? Using the auxiliary function. Yeah. Who else are using? There's no wrong about it, but I want to tell you that you can skip that part. Why? Because we don't need to worry about denominator getting cancelled. Auxiliary function created to avoid this, but there's nothing to avoid here. Does it make sense? Okay, man. Okay, huh? Yeah. So we can immediately do this trick. It's fine. Okay, doing trick here is fine because we don't need to worry the denominator getting 0. They won't cancel because we have condition ff greater than 0. Okay, will it be cancelled? Yeah, it won't cancel, right? Because f is 0, square root of that is 0. The other square root won't get negative also. Okay. At most you get is 0. At most you get. If square root of negative number, then because we are not complex number, so we don't have this issue here. So we will avoid that issue. Does it make sense? Yeah. Okay. So we need to make some sense of this. Okay. Yeah. So so to be precise, right? I think we should specify that fx plus h should be greater or equal to 0. Okay, around x. Okay. Yeah, to be precise, I think we need this condition here. Okay, otherwise it won't work. If it is less than 0, then you need to cry already. Does it make sense? Yeah, because in our case, we don't want to discuss a complex number. Yeah. Actually, there's a secret condition here. Okay. Question 4. For question 4, everyone know we need to apply Rolle's theorem twice, but some of you didn't check the condition and then do it. Okay, so you need to check what? To use Rolle's theorem, what do you need to check? It is continuous at the closed interval and then differentiable at the open interval. Okay, check two things. Okay, you need to check. Okay, don't just apply. Please, please check. Okay, write down. I think I like what Yixing wrote. Yixing wrote everything. Every time if you use a Rolle's theorem, you write all the property. Okay, yeah. That's the way to do it. You need to check. Okay, but what I do is I just write in one sentence here. Okay, to shorten the argument. Okay, in principle, you need to check every time. Okay, for question 5 is quite calculative. So for 5a, you just compute the derivative. I allow you to just differentiate. So why the differentiation works, you should go back to the tutorial 8. Okay, go back to tutorial 8 to see why the differential works like this. Because this is how we define tangent function and cos function here. Okay, so everyone actually did well on question 5a because this is like a high school question. But even like a high school question, but I want you to understand it in a different way. Okay, how do we understand it in a different way? I want you to appreciate the theorem. What's the theorem that I want you to appreciate here? Huh? What's the theorem I want you to appreciate here? Yeah, for 5a. What's the theorem you use? If you know that the first derivative is greater than 0, then the function is increasing. If it's less than 0, it is decreasing. Okay, remember we prove it now. Okay, so remember the proof. And then does this guarantee one-to-one and invertibility or not? Yes. Okay. So because you can prove one-to-one using increasing function here. Okay. Does it make sense? Because if fx1 equal to fx2 and x1 not equal to x2, what happens? Then your function is not increasing, maybe monotone. Not monotone, maybe non-decreasing. Okay, non-decreasing. Because there's some point that is equal. Okay. So yeah. So how do you determine the domain and range of F inverse in this case? So the domain and the range of the F inverse is swapped with the domain and the range for F. Okay, so inverse, the domain of inverse is the range of your F. The range of the inverse of F is the domain of your F. Also they swap. Okay, so they swap. Okay, the last one. Last one here, someone read the wrong question. Ask you to find the F inverse. Derivative of F inverse is not F inverse only. Okay. So to find the derivative of F inverse, what do you need to use? You need to use a theorem. You need to use the inverse function theorem. Okay, so you need to stack that. So what does the inverse function theorem say now? F inverse of x, derivative of F inverse equals to the 1 over of F prime evaluated at F inverse x. And how do you appreciate this? How do you appreciate this formula? How do you appreciate this formula here? How do you appreciate this formula here? And you need to appreciate this formula, otherwise, this is like crazy stuff. How do you appreciate this formula? You see, what normally you do with inverse? For example, 2 inverse. 1 over 2. In this case, you also can think like that, But how do you think of it? You think of it as a 1 over of f prime. Okay. But f prime, you need to evaluate at a certain point. What's the point you evaluate? You exactly evaluate at the point f inverse x. Does it make sense or not? So it's like 那个减一跟那个 prime 交换位置，没有交换位置，减一跑出去啊，prime 跑进来啊，为什么？inverse function theorem 明白吗？大家明白吗？要讲读这个 function，读这个 theorem，减一跑出去 inverse 跑进来，有吗？看得懂吗？看得懂吗？有看得懂这个东西吗？那个 prime 跑进 f 那边了，但是减一跑出去了。为什么我觉得它跑出去？因为2 inverse 等于1/2嘛，我可以想成是 f prime x 1 over f prime x，but we are no longer evaluating at x, we are evaluating at f inverse x. Make sense or not? Why is it making sense? 几点啊 ？You overtime 啊？几点啊 ？OK，我们快点结束。So you doesn't make sense f prime on x, x 活在哪里 ？codomain of f， 所以你一定要带回 domain of f。所以怎样带回来呢？An obvious way to 带回来 is take the inverse. Does it make sense? OK 了，这个是 theorem 哦，是我们 prove 的哦。为什么 prime 跟减一可以这样调一下就可以了？你明白吗？明白吗 ？OK 吗？所以这个是一个很 strong 的一个 theorem 哦 ，inverse function theorem。OK， 为什么我可以减一直接出去 prime 跑进来？但是你要 evaluate 在对的地方哦，你不可以再 evaluate 在 x 啊 ，x 是在哪里的点？那个点应该是在这个f inverse x， 这个 x 在哪里？这个 x 是在 domain 还是 codomain？ 所以你要取对的点放进来，and then 对的点就是 f inverse x，你不可以放 x，OK，、可以吗？呀、因为 f inverse 的 domain 是它的 range，所以你要拿回它的 domain，然后你就拿 f inverse 的 range 反着，OK，OK 啊。Yeah，所以这个是我要你 take care 的地方。Question 6 surprisingly 大家都做的不错，but one thing to take note is 这个大于等于0跟小于等于1。If already equal, then you already found the fixed point already. Correct or not? So you need to assume they are not equal first, strictly greater than 0 and strictly less than 1. Then you can argue using intermediate value theorem. Otherwise, otherwise you already get the result. Correct or not? If you achieve. Correct? If G0 equal to 0 means what? Where is my G the function? You see? If G0 equals 0, meaning that F0 minus 0 is 0. You already get the fixed point, right? Okay, so you need to get rid of these conditions first. Okay? Does that make sense? Yeah, so it's this line here. Okay, this line. If G0 equals 0 or G1 equals 0, then you are done. So suppose you don't have these two cases. Strictly, we need to be strictly greater than 0 and strictly less than 1. Okay. Sorry. Strictly greater than 0, strictly less than 0. Okay. In this case, did I make some mistake here? I think I made mistake here. This one need to change. Okay, and then the last question, I think for those who did it, I think did quite well. You just need to follow my step here. But some of you didn't follow my step, so that's why you miss out some details. Okay, it's as long as you follow the step, and then most of you didn't explain is base case. Why base case word? Base case is really trivial. But why is it trivial? Do you know? Why is it trivial here? You want to choose fx not 0 g0x equals to f0 of x0 and then g0 of x0. But what is the x0 you can pick here? I just pick the same x is enough. Okay, that's why it's trivial. Okay, for other x and you need to use the Cauchy generalization mean value theorem. And then one technical part you need to explain is when you use Cauchy-Riemann, Cauchy mean value theorem, right? Why the FMC part and the GMC part is 0? You didn't explain well, some of you. Okay. It is because that these two things equal 0, then you can have this kind of chain here. Okay, because the constant term there is already 0. That's why in this hint here, I ask you to discuss what is FMC and GMC. Okay, because they are 0. Okay or not? So these are the technical point here. If I don't give you this hint, do you know how to do this question or not? Okay, agak. Last time when I do this question, my hint don't have this line. Just give us FM and GM and then tell us to prove this. This is what I had last time. Yeah. Yeah. Okay. Yeah. Actually, okay lah. This question you guys did it. Yeah. Get the big picture. So there's some small part you need to argue the base case and then the why is it 0 when you evaluate FM and GM, why is it 0 when you evaluate at C.